Have you ever wondered how WhatsApp manages to handle over 50 billion video and voice calls every single day without collapsing? That's nearly 600,000 calls every second. What if I told you there's a secret technology running behind your WhatsApp that's completely revolutionized how we communicate? Today, we're going inside WhatsApp's hidden WebRTC infrastructure that powers the calls connecting billions of people worldwide. Before we dive deep into WhatsApp's calling architecture, let's take a second to understand just how massive this operation is. With over 2 billion active users globally, WhatsApp processes more calls daily than the entire traditional phone system did at its peak. And unlike traditional phone calls that use dedicated circuits, WhatsApp has to send all this data over the internet, which was never designed to handle real-time communication reliably. But somehow, your calls connect in seconds, sound crystal clear, and rarely drop, even on sketchy networks. So how does this technological miracle happen? The answer lies in WebRTC, Web Real-Time Communication, the powerful open-source technology that WhatsApp has masterfully implemented and scaled. But WhatsApp didn't just use WebRTC out of the box. They completely reinvented it. At the foundation of WhatsApp's infrastructure is a programming language most people have never heard of, Erlang. Originally developed by Ericsson for telecommunications systems, Erlang's superpower is handling millions of concurrent connections with minimal resources. Unlike typical web servers that might handle a few thousand connections, a single WhatsApp server can manage up to 500,000 simultaneous connections. This is crucial because when you make a call, your phone needs to maintain a constant connection to WhatsApp's servers. What's even more impressive is how WhatsApp scales this system. Instead of using complex distributed systems like many tech giants, WhatsApp deliberately kept things simple. Each server handles a specific subset of users. Servers are organized in clusters for redundancy. User data is sharded across multiple databases for speed. Now let's explore WebRTC itself. When you hit the call button on WhatsApp, here's what actually happens. 1. Your phone sends a signal to WhatsApp servers saying you want to call someone. 2. The server locates your friend's phone and sends a notification. 3. When they accept, WebRTC begins a complex process called signaling. During signaling, both phones exchange something called SDP, Session Description Protocol. Think of this as both devices sharing a detailed list of their capabilities. What video codecs they support, what audio quality they can handle, and more. But here's where things get complicated. Most phones are behind firewalls, or NAT, Network Address Translation, which makes direct connections nearly impossible. This is where stun and turn servers come in. Stun servers help phones discover their public IP address, while turn servers act as relays when direct connections fail. WhatsApp operates hundreds of these servers worldwide to ensure calls can always connect. While WebRTC provides the foundation, WhatsApp's engineers have implemented countless optimizations that make their implementation superior. 1. Adaptive bitrate. WhatsApp constantly monitors your connection quality and adjusts video and audio quality in real time. That's why calls don't immediately drop when your signal weakens. 2. Custom codecs. WhatsApp uses specialized audio codecs like Opus that can deliver clear voice even at extremely low bit rates, as low as 6 kilobits per second, which is critical for users in regions with poor connectivity. 3. Efficient transport. Rather than standard TCP, WhatsApp uses UDP with custom reliability layers for faster transmission with less overhead. 4. Peer-to-peer architecture. When possible, WhatsApp establishes direct connections between callers, bypassing servers entirely for lower latency and better quality. To deliver consistent performance worldwide, WhatsApp has built an impressive global infrastructure. Data centers strategically positioned on every continent. Edge servers that bring connection points closer to users. Partnerships with ISPs for optimized routing. This global presence is crucial for international calls. When you call someone across the world, WhatsApp's infrastructure ensures your data takes the most efficient path possible. And remember those turn relay servers I mentioned? WhatsApp has thousands of them, ensuring that even if you're behind the strictest firewall in a corporate office or certain countries with restrictive internet policies, your calls can still connect. One final piece that makes WhatsApp's calling system remarkable is how they've implemented security without sacrificing performance. Every WhatsApp call is protected with end-to-end encryption, meaning not even WhatsApp can listen in. This encryption adds computational overhead, but WhatsApp optimized it to add minimal latency. The system generates unique encryption keys for each call, verifiable through security codes visible to both parties. This level of security at WhatsApp's scale is unprecedented and represents one of the largest encrypted communication systems ever built. So where does WhatsApp go from here? The team is constantly pushing WebRTC technology forward. Implementation of AV1, a next-generation video codec that provides better quality with 30% less bandwidth. AI-powered noise suppression that can eliminate background noise in real time. Improved group calling that can handle larger groups with less network impact. But perhaps the most exciting development is how WhatsApp is optimizing for the next billion users, those coming online with low-end devices and intermittent connectivity. Engineers are developing techniques that can maintain call quality even when packets are lost for several seconds. WhatsApp's WebRTC implementation is a masterclass in scaling technology to serve billions of users. From custom codecs to global infrastructure, every aspect has been optimized for reliability, quality, and accessibility. Subscribe now for the latest tech reviews, tips, and updates. Stay ahead in the tech game.